going to solve this equation. 8 raised to x minus 2 raised to x over 6 raised to x minus 3 raised to x equals 2. We have to find the value of x where x belongs to integers. So here first we are going to turn 8 into the base of 2. As 2 cube is 8, so we have to write that down. So 2 cube whole to the power of x minus 2 to the power of x over 6 can be written as 2 times 3. So 2 times 3 whole to the power of x minus 3 to the power of x equals 2. Now we can see there's power to power rule, so we multiply the powers. We get 2 to the power of 3x minus 2 to the power of x over, we have product to a power, so each factor is raised to that same power. 2 to the power of x times 3 to the power of x minus 3 to the power of x equals 2. Now we take 2 to the power of x common from the numerator, so we are left with 2 to the power of x times 2 to the power of 2x minus 1 over, here we are going to take 3 to the power of x outside, so we are left with 2 to the power of x minus 1 equals 2. Now we are going to write it as 2 to the power of x into 2 to the power of x the whole square minus 1 square over 3 to the power of x times 2 to the power of x minus 1 is equal to 2. So we have an identity here. As you can see, it's a square minus b square. So we're going to write that a square minus b square is equal to a plus b times a minus b. And then just substitute back in 2 to the power of x into 2 to the power of x plus 1 times 2 to the power of x minus 1 over 3 to the power of x times 2 to the power of x minus 1 equals 2. We can cancel out 2 to the power of x minus 1 from numerator and denominator, provided that 2 to the power of x minus 1 is not equal to 0 and 2 to the power of x is not equal to 1, so x is not equal to 0, provided this condition. So now we have 2 to the power of x times 2 to the power of x plus 1 over 3 to the power of x equals 2. We are going to multiply 3 to the power of x on both sides to eliminate it from the denominator. So we can cancel out this, and we are left with 2 to the power of x times 2 to the power of x plus 1 is equal to 2 times 3 to the power of x. Now to eliminate this 2, we are going to divide both sides by 2. So we are going to get 2 to the power of x minus 1 times 2 to the power of x plus 1 equals 3 to the power of x. Now let's say for x is greater than or equal to 2, we have, let's say from equation 1, 2 to the power of x minus 1 times 2 to the power of x plus 1 is equal to 3 to the power of x. That is our equation 1. Substitute x is equal to 2 or greater than 2. We find that this is even and this term is odd, and 3 to the power of x is odd. So even times odd is again even, and even is not equal to odd. Therefore, we don't have any solutions if x is greater than or equal to 2. And if x is equal to 1, 2 to the power of x minus 1 times 2 to the power of x plus 1 is equal to 3 to the power of x as per our equation 1. We are going to substitute x is equal to 1 in that. So 2 to the power of 1 minus 1 times 2 to the power of 1 plus 1 equals 3 to the power of 1, which is 1 minus 1 is 0. So 2 to the power of 0 times 3 is equal to 3. So 2 to the power of 0 is 1. 1 times 3 equals 3, so 3 is equal to 3, so x is equal to 1 is the solution. Now if x equals to negative n, where n is greater than or equal to 1, we are again going to take our equation 1, that is 2 to the power of x minus 1 times 2 to the power of x plus 1 is equal to 3 to the power of x. Now let's substitute x is equal to negative n. 2 to the power of minus n minus 1 times 2 to the power of minus n plus 1 is equal to 3 to the power of minus n. Now we are going to take out negative 1 common, so 2 to the power of minus 1, so we are left with n plus 1 inside, times 2 to the power of minus n is the reciprocal of 1 over 2 to the power of n, plus 1 is equal to, again you have reciprocal, so 1 over 3 to the power of n. Now we have again negative exponent, so reciprocal of that is 1 over 2 to the power of n plus 1 times, now we take the LCM, so we are left with 2 to the power of n plus 1 over 2 to the power of n equals to 1 over 3 to the power of n, and that's equal to 2 to the power of n plus 1 in the numerator, and in the denominator we have 2 to the power of 2n plus 1 is equal to 1 over 3 to the power of n. And then we cross multiply 3 to the power of n times 2 to the power of n plus 1 equals to 2 to the power of 2n plus 1. As we already know n is greater than or equal to 1, so 3 to the power of n is odd, 2 to the power of n plus 1 is an odd term, and 2 to the power of 2n plus 1 is an even term. And odd multiplied by odd is odd, which is not equal to even. So x is equal to negative n has no solutions. The only solution is x is equal to 1. Thanks for watching.